Hello, I'm Shekhar, and what you're seeing here is an AirJet Mini integrated into iPad Pro. Uh, we took an iPad commercial COTS iPad Pro, removed the current heat, the spreader and the graphite sheet that is only used to cool the system. With that system, at best you could get is 13 watts of system cooling. Once integrated with an AirJet, we are able to push the performance by 24%, take 13 watts of cooling to 18 watts. Right? So how did we do it? We designed a custom vapor chamber, integrated into the system, put two minis in there, and the air would actually flow through the system, create a wash, get into our AirJets, and efficiently remove the heat. So here is a couple of demos showing you that we ran through a benchmark, standard benchmarking tools that shows better performance. Also, the gaming experiences are better due to the increased frame rates that you get with the increased system power. We're showing that with the AirJets, the system is actually pulling 18 watts, as opposed to a standard system which does 13 watts performance. So it opens up a whole immersive gaming experience with vivid display, better frame rate. So overall, the experience of using an iPad is amplified. Yeah. Then just moving, the other key thing is the thickness of this system is 5.1 millimeters. There's no fan that can be integrated into the system to get the similar performance. Given that we are only 2.5 millimeters thick, we can get into this thinner form factor and still increase the overall system performance. While being silent, since we operate at ultrasonic frequencies, the AirJet itself doesn't create any audible noise. It operates around 24 kilohertz, so normal human hearing don't hear it, and it creates a silent, good performance. Yeah. We took the same AirJet and put it into a MacBook Air. Yeah? The MacBook Air is 7.4 millimeters. And if you compare that to a MacBook Pro, which is 10.4 millimeters, and in the MacBook Pro there is a fan. But in MacBook Air, given that the base thickness is only 7 millimeters, again, they went with the passive solution. With the passive solution, as you can see here, it can sustain 12 watts of CPU power. Now, we put in 3 AirJet minis, and then the same MacBook Air is now performing at 20 watts, which is same as a MacBook Pro. So the thickness is still 7 millimeters as opposed to 10.4, but the performance is same as a MacBook Pro and being silent, right? So you get the best of both the worlds, where you have a better form factor, full performance, and silence. So then moving on to an X-Elite chip, which is the new Qualcomm's compute platform. So this is a Samsung Book 4 Edge, and this has 2 fans in them. One big fan and a slightly smaller fan. We removed the fan, again designed a custom vapor chamber, and put in 4 AirJet slims. What does that translate to? One with the fan can sustain 12 watts of sustained performance. We were able to bump it up to 18, and at the same form factor, right? This, while being dust-proof, water resistant, silence, all the features carries on all the products that we're talking about. Another thing that if you can notice is we have actually additional space that is available. How do we use the space? You could increase the battery. So you can pump up the battery from 56 watt hour to a 55 watt hour. That's an additional 16% increase in the battery size and giving you more performance. Right? So again, you can see the plot difference. This is with the AirJet, sustaining 34 watts of system power as opposed to 24 watts on just the COTS. Okay? Since this is scalable, we took one mini and we were able to put it in the phone as well. And in the phone, given that these are commercial products, we were able to push the performance, and it always runs at 5 watts. But what you can clearly see here is the red curve showing the skin temperatures, which is key when you're handling the phone, right? It's running at 48 centigrade, but when you have the AirJet, it runs much cooler, 6 degrees cooler, and it's running at 42 degrees Celsius. So again, what can we do with 6 degrees? You can bump up the performance or choose to run it cooler. We could do all this while creating a water-resistant, waterproof device. How do we do it? We have a little video here that kind of shows how we could integrate. We are creating a separate cavity where we could put our AirJet Sport in. AirJet Sport is this one of our products that can operate when it is immersed in water. We don't need to run the AirJet Sport because water can do the cooling for you. But once it dries up, our device can operate normally. So essentially what we do is we create a separate chamber in which our Sport sits, and the rest of the system is completely sealed. You could have water come into this chamber, but once it dries up, we are okay to operate. Right? Not many people need to run workloads underwater, so it should be fine, right? So when the video rolls, you will see that there is, we have created a chamber, and we haven't increased the overall thickness of the phone, but what we have used is generally the camera lenses, which are already thick, and there is a bump at the back. We just extend it so that the overall phone experience of holding and the overall is still the same. And even that we are a smaller device, we could still get in that chamber and create the whole experience. So we could run it 6 degrees cooler or increase the performance.